Okay, just imagine for a second, a single structure so incredibly tall it literally seems to pierce the clouds. A modern wonder of the world that completely redefines what we thought was possible for humanity to build. Well, that's the Burj Khalifa.
So here it is, standing tall in Dubai. And the Burj Khalifa is, and this is no exaggeration, the tallest structure ever built by human hands. It's so much more than just a building. It's a statement, a symbol of pure ambition and a true marvel of modern engineering.
And to give you some perspective on that, it's 828 meters tall. You could stack 3 Eiffel Towers, one on top of the other, and the Burj Khalifa would still be taller. I mean, that's a scale that's almost impossible to wrap your head around.
So that brings up the big question, right? Why? Why build something so ridiculously colossal right in the middle of the desert? What was the vision driving this absolutely monumental project? Well, here's the core idea, and it comes straight from its architect, Adrian Smith. You see, the Burj Khalifa was never meant to be just a standalone tower. It was designed to be the glittering centerpiece of a brand new downtown Dubai, a catalyst, really, meant to drive development, pump up the value of everything around it, and put Dubai firmly on the global map. And get this, the timeline was just incredibly ambitious. We're talking only 6 years from the moment they first broke ground to the grand opening. In 6 years, this structure that looks like it belongs in some sci-fi movie became a reality. That's a truly staggering pace for a project this massive. Okay, now let's get into one of the biggest challenges. I mean, building tall is one thing, but making a needle-thin tower survive powerful desert winds? That is a whole different kind of engineering puzzle.
So, how do you even solve a problem like that? How do you make sure a building this tall doesn't just sway like crazy, or, even worse, fail against the constant push of nature's forces?
Well, the answer, believe it or not, comes from nature. The design team took inspiration from a regional desert flower, the Hymenocallis, and that inspiration led directly to the complex engineering you see here, this very distinct Y-shaped, triple-lobed footprint. This unique shape, which spirals as it goes up, is the first secret to its stability.
And at the very heart of that design is the tower's secret weapon, the buttressed core. This was a revolutionary system developed by structural engineer Bill Baker. You've got this super strong hexagonal core in the middle, and it's supported by 3 wings that act as buttresses. This whole setup gives it incredible strength against both twisting and sideways forces.
And the advantages of this system are huge. It gives the tower that excellent wind resistance we were talking about. It also means they could use materials way more efficiently. This is the kind of design that lets you build taller and more slender towers. And hey, it also happens to create a really unique and beautiful look. It's a win-win-win.
So we've got the vision, and we've got the clever design, but how do you actually build it? The sheer scale of the materials and the logistics involved, it's just mind-boggling.
The construction took 330,000 cubic meters of concrete. That's a number so massive, it's pretty much impossible to grasp on its own.
So let's try this. All that concrete has the same weight as about 100,000 full-grown elephants. Yeah, you heard me. 100,000 elephants, all made of concrete. And that concrete was reinforced with 39,000 tons of steel rebar. If you were to lay all that rebar end to end, it would stretch over a quarter of the way around the entire world. Just incredible.
And all of that sits on a massive foundation. The whole structure is supported by 192 piles of steel and concrete, each one drilled 50 meters deep into the ground just to anchor this giant tower firmly to the earth.
You know, one of the biggest hurdles was just getting the materials up there. The team had to pump a special high-performance concrete to a world record height of over 600 meters. This had never been done before, and it required tons of testing and brand new technologies just to stop the concrete from hardening in the pipes on its way up.
Even the very last piece, the 200-meter spire, was an engineering feat all by itself. This part is just genius. Instead of using a giant crane on the outside, the team built the spire from inside the building. They actually assembled the pinnacle inside the main structure and then, piece by piece, used powerful hydraulic jacks to lift it up into its final, soaring position. What a clever solution.
So, when it's all said and done, what's the Burj Khalifa's lasting impact? Well, it's so much more than just a record in a book. It's a global icon that completely changed a city forever.
I mean, the numbers really speak for themselves here. The Burj Khalifa is nearly double the height of the Empire State Building. It's almost triple the height of the Eiffel Tower. It is just in a category all on its own.
And this thing is not some empty monument. It's a bustling, vertical city. It's got the Armani Hotel, luxury residences, corporate offices. It has the world's highest swimming pool, a world-class restaurant, and, of course, those observation decks with views that will take your breath away. And it's all connected by some of the fastest elevators on the planet.
In the end, the Burj Khalifa is so much more than just the world's tallest building. It's really this powerful testament to human ingenuity, to global collaboration, and to that relentless, ambitious drive we have to not just reach for the sky, but to actually build a permanent home up there among the clouds.
The story of the Burj Khalifa totally redefined what we thought was possible. And it leaves us with this really fascinating question. If we can build this, what's next? And are there any limits left for us at all?